Okay, Kabir, I think you must be observing the screen now. Okay, let's quickly cover the concepts of surface area and volume, and then we can go with question sets. Actually, only the surface area if you want, then 2D figures can also give you surface area. But if you want both surface area and volume, then we have to discuss 3D. In 2D, we can consider the discussion on triangle, we can discuss quadrilateral, we can discuss circle. All these have their area, they all have their perimeter, they have their area, they have their perimeter. Circle also have area, circle also have circumference. Generally, for triangle, it is half base into height. Perimeter is simply sum of all sides. In case of quadrilateral, we can determine area and perimeter, but what quadrilateral it is, it depends. If it is parallelogram, then area is going to be simply base into height. If it is square, then area is going to be side square. Let's say side is A, then A square. If it is rectangle, then area is length times breadth. If it is rhombus, then area is how much? Half D1 into D2. If it is trapezium, then area is half sum of parallel sides into distance between them, that you can take height. Like this is your trapezium, then distance between these two. And this is A, this is B, then this is H. You can also call it half A into B into H. Half A plus B into H. Rhombus you can draw, it's a figure that has all the sides are equal. In rectangle, opposite sides are equal and parallel, and one angle is 90. In square, all the sides are equal and one angle is 90. In parallelogram, pair of opposite sides are parallel. Actually, all square are parallelogram, all rectangles are parallelogram, all rhombus are parallelogram. In fact, vice versa is not true. Perimeter, you can use the same formula, sum of all sides. Whether it is any type of quadrilateral, you need to take sum of all sides. Even you can have pentagon, you can have hexagon, you can have heptagon, you can have any polygon. The formula to be used for perimeter is same. In case of circle, circle is a figure having a center and a fixed distance of center from all collecting points that we call radius. That's why area over here is pi r square. Circumference is equal to perimeter. In case of circle only, that's 2 pi r. And there can be other area related to circle that we can discuss in our other classes. Yes, they may be sector, segment, quadrant, all these can be there. If you want to discuss quickly, you can. If you take half of the portion, you call it semicircle. In case of semicircle, now the area will be half of the circle, obviously. And the perimeter will be different than the circumference. Circumference only include that part which is circular, that part which is in the arc form. And over here, that part is half of your 2 pi r, obviously. That is pi r, isn't it? But the perimeter includes, this portion is your semicircle. That's why perimeter includes both the radii as well, total corners as well. That means twice r you have to add, or diameter you have to add. Not only semicircle, related with your circle, you can have 1/4 part. That means this part. What do you call to this?
Quadrant.
We call it quadrant. Yeah, exactly. And this quadrant, if you want to figure out its area, the area goes like this. Area is 1/4 of that of the area of circle. And if I ask you to find out circumference, it will be 1/4 of that of circle. If I ask you to find out what we call perimeter, it will be circumference plus diameter. R plus R, that you call diameter. Because you have to include these both coordinates. That's why it becomes twice R. Okay, not only semicircle and quadrant, we can have other things related with circle, like we can have sector related to circle, we can have segment related to circle, because sector and segments are derived out of circle only. How do we derive them? I'm telling you that. If you want to get sector, you have to consider an angular part. You can take any angle theta. That means you are having two radii and you take the area between these two radii and this corresponding arc. Then if you then if you consider this area, you call it sector, and you just use unitary method. If you take this entire angle 360, the area you get is pi r square. That is why if you take 1 degree, area you get is pi r square over 360. That's why if you take theta degree, area you will get will be theta into pi r square over 360. It's a simple unitary method you must have used in even lower classes. That's why finally you got area sector, that is theta over 360 pi r square. And not only area of sector, you can even find the length of this arc. How will you find this length? Same concept you can use, theta over 360, but here rather than using pi r square, you have to write 2 pi r. This will be your length of arc. In same manner, you can find out the segment. Segment is that part of circle which is obtained by taking a chord and corresponding arc. That means if you join these two chord in with center, you will get sector as well. Yeah, you will get sector if you join it with these. You will get sector. That means if you take sector and you subtract triangle, you get segment. It's easy to find out area of segment by considering area of sector and subtracting that with the area of triangle. I will just suggest you to use area of sector minus area of triangle to find out the area of segment. In this way we can have semicircle that is related to circle, we can have quadrant that is related to circle, area related to circle, we can have sector, and sector by default means minor sector, segment by default means minor segment. Sector and segment both by default means minor, and if you want major, you just have to subtract your circle area with that minor sector or minor segment. You will get major sector and major segment. Actually, remaining area is your major sector. And here the remaining area will be your major segment. Okay, actually these part will be covered under area related to circle. These part that I explained, triangle and quadrilateral parallelogram, this will be covered under 2D. But today I am going to focus on 3D. I have just told these scenario, these formula, so that you can write them and you can just quickly memorize them, recall them. I will share the PDF as well, don't worry. But the main thing that we are supposed to cover today is 3D shapes, 3D figures, because we are going to cover both surface area and volume. And surface area and volume both are there for 3D figure, that means for solid figure. And under solid figure we can have two type of solid figure. Do you know what are those two types? One is solid of polyhedron, where we bound the surfaces, and all around, like right now the room that I'm sitting here or you are sitting there, all the walls and including your roof and floor makes the solid of polyhedron, that is maybe cube or cuboid, there may be cube or cuboid or prism or pyramid. These are generally solid of polyhedron. Even tetrahedron is there, that is solid of polyhedron. Other than solid of polyhedron, we can have solid of revolution in our 3D figures. What are different solid of revolution? We can have sphere, we can have hemisphere, we can have cone, we can have cylinder. All these are solid of revolution. Now we will discuss them all in much detail with all their formula. Okay? Quickly revise all these contents. Let's start with some of the solid. And the first solid in our discussion is cube, and the second solid in our discussion is cuboid. About these two solids, if we want to learn about these two solids, the first thing to understand is its shape. If you want to draw the shape of cube, actually its all surfaces are square. You just need to remember all the surfaces are square around your cube. That means a cube is a solid, a cube is a 3D solid, three-dimensional solid whose all the surfaces are square. If you are given with one of the edge being A, then all the edges you need to consider as A. Here you remember we have also Euler's formula that we can apply for such solid. Do you remember that Euler's formula? Yeah, sure, I will. Actually, you have edges here that you can count. You have phases here that you can count. And other than edges and phases, you have vertices that you can count, or vertices that you have. Can you count the vertices? A, B, C, D, E, F. Let's say this is G and this is F. These are 8 in number, these are vertices. If you want to count edges, 4 edges are there on top, 4 edges are there on bottom, and 4 edges are vertically. There are total 12 edges. If you want to count phases, the front face just opposite to front, side face just opposite to side, top face just opposite to top, bottom face. That means total 6 phases are there. Based on these numbering that I told you, number of edges, number of phases, number of vertices, we have a relation that's called Euler's formula, which goes like this: F plus V is equal to E plus 2. Many times you may be asked to verify this Euler's formula, or maybe questions based on a relation based on this is there in your exam. Quickly do write it and you can just verify it here. Your phases are 6 in number, vertices are 8 in number, edges are 12 in number. You obtain LHS 14 and even RHS is 14. That means Euler's formula is verified. The question even arises, where are we going to verify it? We are going to verify it for all convex solid. Even for cuboid you can verify it. If you want to try, you can, because in case of cuboid the solid has rectangular surfaces and maybe some square surfaces. It looks like this that I'm drawing here. This is your cuboidal figure. It is a 3 three-dimensional figure. That's why we even call it solid. And this solid has both surface as well as it occupies space. That's why it has volume. Here length, breadth and height are not same. Here length, breadth and height are not same. Length, breadth and height are different. Now if you want to find out some parameters related to cube, I will tell you that. But the phases, edges and vertices are same here in cuboid as well. What are different parameters that you need to quickly recall? The first parameter is lateral surface area or four-wall area. Second parameter is total surface area. Third parameter is volume. And fourth parameter is body diagonal. These are four parameters associated with all of two, that means cube and cuboid. What is its lateral surface area or four-wall area? What is its total surface area? What is its volume? What is its body diagonal? Let's quickly go through that. Lateral surface area or four-wall area is going to be area of four walls except your roof and your floor. That means you have to just cancel your two areas in your total surface area. Actually all the sides, all the phases are square. That's why these are going to be 4L square. 6L square is TSA. Volume is base area into height. For all two bases figure where you have two bases, where you have one base, your volume is going to be 1/3 base area into height. Where you have two bases, your volume is going to be base area into height. Like it will be there for cone, this formula will be there for pyramid, and this formula will be valid for prism, even valid for cube, cuboid, cylinder as well. Yeah, base area is over here, A square, height is also A, or L, whatever you assume. If I'm writing A equal to L, then you can go like that, go like this. It's L square into L, L cube, and body diagonal is √3L. Body diagonal is that length which you can place in your room. The longest length or longest length of a rod that you can place in your room will be this body diagonal. Same body diagonal means if you just you can just observe my position. You can take a corner and the bottom corner, and the rod that you can place in your room will be your body diagonal. And LSA is lateral surface area for this figure, which will be you will exclude your bottom area. That means LB you will exclude and upper LB you will exclude. That means you will include BH 2 times, you will include HL 2 times, you can take 2H common, L plus B, this is your LSA. In TSA you will also include 2 LB, that's why you can take only 2 common, and you will be left with 2 LB plus BH plus HL. In volume you will take the lower area LB and you will take multiply by height. In body diagonal here it is root L square plus B square plus H square. I remember you have already written it, and if you want to take a screenshot, quickly do that. Even I will share the PDF if you want. Quickly revise it. In 2 minutes I will help you revise the content. Then we can start with some interesting MCQs. Should I move further with the other two figures? Yeah, sure. Okay. Okay, have you written it? If you want to write something from upper part, you can do that. You have taken. Okay, okay, then that's fine. That's good. That's good. Okay, now if you have written up to this or taken the screenshot, we can move further and we can discuss other two figures that I have. Other two figures that I want you to go through is the figure number 3rd and 4th, and let's discuss the two figures that are cone and cylinder. These are the solid of revolution. Let's discuss them. Cone looks like this. A cone has this type of geometry. It's obtained by revolving a surface. There is a apex here, there is a bottom here, the base here, and this is called base radius. This is the height and this is the length, slant height that we call. And there is a right angle triangle over here. And we have covered, if you remember, we have covered the Pythagorean triplets in much detail. And here we have Pythagoras theorem that we can apply, which says that the square of longest side is equal to sum of square of other two sides. We can even determine the hypotenuse directly from this relation. And even we can develop a Pythagorean triplet, that is L square minus 1, 2L and L plus 1. And in this triplet, we start with the value 2 actually. If you put L being 2, you can get the 3 triplet being 3, 4 and 5. Similarly, you can put L being 3 and you will get 8, 6 and 10. And there can be many triplets that you can obtain. These are called Pythagorean triplets. We have covered this topic in much detail when we were discussing Pythagoras theorem. I have taken this topic separately in your request, if you remember. You can quickly revise this. Yeah, I have just told this so that you can well recall it. Okay, here we can apply this relation of Pythagoras theorem. And it is H here, it is R here, it is L here. If you apply this relation, your L square will be H square plus R square. The second relation over here is the curved surface area. Because here the portion is curved, that's why we call it curved surface area. And by taking curved surface and base area, you will be able to take total surface area, which is the curved surface area plus base area. That is pi RL plus base area is circular. That's why here you can take pi R common. And the volume will be 1/3 base area is pi R square and height is H. I have already told that for one basis, we use 1/3 base area into height for the volume. Then come to the figure cylinder. Cylinder has two bases now. And it's also obtained by revolving the surface. That's why we call it the figure of revolution. Here, if you want to find out the first relation, it is the curved surface area, which is 2 pi r the base length, and it goes up to h. The total surface area is simply CSA plus both base r square. Below base is pi r square, above base is pi r square. You can take 2 pi r common. The volume can be obtained if you use the formula base area into height. And in this way you have this much relation. And finally you come to, if you want to write it down or take a screenshot, you do that. And then we can go with, tell me if any difficulty. Yes. Okay. So far I'm just helping you with the quick revision. I have started with the basic of 1 minute. I have started with the basic of 2D, 3D, and I have just helped you recall the concepts related to all 2D figures, triangle, quadrilateral, and circle as well. Then I have helped you with solid. In solid we covered cube, cuboid and cone and cylinder so far. Now we can move with other two solid that are there in detail in our syllabus. Other two solids, the fourth solid, four we have already discussed. The fifth solid we can discuss as a sphere, and the sixth solid we can take as hemisphere. Let's discuss these two solid in detail now. A sphere is a cricket ball. If you take cricket ball as an example, cricket ball is actually a sphere. Cricket ball is a sphere whose radius you can take, and the serving bowl that we use in our kitchen is going to be the spherical shape, or the example of hemispherical shape. Obviously it is half part of your sphere. Here we can have curved surface area and total surface area and volume to discuss. Curved surface area is there, total surface area is there, volume is there. Curved surface area is 2 pi r square. Even the volume is same here, TSA is same here, but volume is 4 over 3 pi r cube. For this volume will be half. CSA will be 2 pi r square, half of your circle, but TSA will include the above base area, which is 3 pi r square. You have to add curved surface area and base area pi r square. You will get 3 pi r square as your total surface area. After this we can have a spherical cell to discuss. There can be hemispherical cell. There can be cylindrical cell. What is it? Like if you have a sphere not in solid form, if a sphere is not in solid form, rather it is in this form, you call it a spherical cell. If you want its volume for this part, you will subtract the volume of two sphere that you observe. You have to take radius of a smaller part and radius of the larger part. And you can consider the volume 4 over 3 pi capital R cube minus a small r cube. Same you can do with hemisphere and cylinder. When we get such question, we will go with that in this manner. We will observe the scenario that time, but we will approach like this. Okay, all right. Cylindrical cell will look like this. This type of cylindrical cell may be there. You may be asked to find out the volume of this part, like when water flows through pipe. Generally, the pipes are hollow form. That's why the volume of metal used to make such solid will be pi r square h, capital R square minus a small r square into height. Is if it is h, we will write h. Same with hemisphere. The volume will be 2 over 3 pi capital R cube minus a small r cube. Okay, let's start with some questions if you are okay up to this, or okay with all the discussions we did so far. Let's do, yeah. I'm presenting some questions that I want you to do quickly, and those questions are here in front of you, and let's go with these questions. First you observe this question that is in the solved form. In a cylinder, if radius is halved, okay, what happens if you are given with a cylinder, but your cylinder is this form? It's having radius r, height h. In the second scenario, what you did is you will find the volume pi r square h. But now you have half the radius and you have doubled your height. Let's see what happens if we do so. If radius is halved, height is doubled, then volume is going to be pi r square into h. If we solve it, we will get pi r square over 4 into 2h. This 2 to the 4 will give you 1 by 2 pi r square h. And this is only the volume of first part. Let's say it is V2, it is V1. Then the V2 become 1 by 2 V1. That means volume is halved, isn't it? That's why the answer is C. This is a sample question that is in solved form. Now the questions from all those 6 cases and even cell part may be there that we covered so far are going to be here in this exercise. You can start with the first question. I'm giving you 4 minutes to solve, rather 5 minutes to solve initial 4 questions. You start your work first. These 4 questions are there. You take 5 minutes to solve them and then we can move further. I think you must have appeared them all because they are not easy. Okay. Okay. Okay, fine, we can discuss them. The radius of a sphere is twice r, then its volume. Okay, volume is 4 over 3 pi r cube. 4 over 3 pi. In the place of r, you will put 2r into 2r into 2r. You got 2 to the 4 to the 8, 4 the 32. 32 divided by 3 is there, pi is there, r cube is there. Option number D, obviously. Is it your answer? Okay, fine. Okay, now you go with the question number, you can appear the question number. Okay, let's appear the second one. The total surface area of cube is given to you. And do you remember the total surface area of cube? What is the total surface area of cube? Okay. 6 side square. That means 6 times L square is 96. 6 you can divide both side and you will get how much? How much? 16, and that's why L is 4. L is 4, that indicates volume is 4 cube. And 4 cube is 64. Yeah, exactly. Okay, well done. Can you answer third one? Exactly, it is conversion based question because you are converting your cone into sphere. Volume will be same here, isn't it? And if you are having cone and you are converting it into sphere, what is the volume of cone you need to recall? It's 1 over 3 pi r square, that means 2.1 into 2.1 into h, that is 8.4. It need to be equal with the volume of your sphere, which is 4 over 3 pi r cube. R you want actually. Okay, okay. 3 got cancelled, pi got cancelled, 4 will give you 2.1, and that's why r cube is 2.1 cube. If your bases are same, if your power are same, base must be same. 2.1 you got it very easily. Okay, can you try answering fourth? Yes. Yes, this is cylinder, you can assume it to be of height h and radius r, but now you have doubled the radius and you have halved the height, and if you have doubled the radius and you have halved the height, earlier the volume, let's say V1 was pi r square h. Now the volume is going to be pi twice r square into h by 2. That's coming out to be pi. No, you did mistake if you did that like that. It's going to be 2 times 2, 4. It's twice pi r square h we got. That's why V2 is twice V1, because this is V1. It's not same, it's doubled. Yeah. Okay, that's okay. Come to the question 5. Try answering it. Yeah. Okay, try to answer 5, 6, 7, 8. You have now 4 questions in front of you that you can appear quickly. One minute, 1 minute. Okay, I think you can see it now. The total surface area of cone whose radius is r over 2 and slant height is 2l. These questions are basically based on the formula that we have covered today. All these formula that we have covered, the questions are based on these formulas. That's why I have helped you with these 6 basic formulas. Cube, cuboid, then cone, cylinder, and then sphere, hemisphere. We are making use of these formulas in these questions. Here we are making use of the cone. You want to figure out cone especially. Okay, tell me, appear it first. Okay, you tell me answer to this first. Okay. Okay, let's discuss them all quickly because there are 10 something questions I have considered for today's discussion. Let's quickly go through them all. And so far we have done up to 5. In the 5th question you have total surface area you want, that is simply pi RL plus base area pi r square. That's what you will get. Pi 2 got no, okay, you don't cancel 2, rather you do a thing, pi r 2 pi RL and you multiply by 2 and divide by 2, because here you have pi r square by 4. Okay, if you now take okay, actually they have done r by 4. Okay, all right, if they have done r by 4, then what you can do is you can simplify. How will you simplify? You will cancel this 2, you will get pi RL here and you will get pi r square by 4 here. Now you will take pi and r common, you will left with L plus r by 4. The option number B will be your answer. Okay, is it yours as well? Okay, then try answering 6th. Actually you have total 10 questions here that I want you to appear today. Let's do them quickly now. Question number, the radii of 2 cylinders are in the ratio 2:3 and their heights, actually pi r square h, pi r square h over pi r square O into h. Pi cancelled, 20 over 27 that is B option. Let's do them quickly now. Lateral surface area of cube is simply 4L square, and if you divide here, it's 64, L is 8. If L is 8, the volume is cube of 8. What is the cube of 8? 512. Yeah, come to the question 8 quickly. Yeah, they are the easy basic questions that we have today in the discussion, but they are helpful. They are making use of the formula. That's why you have to recall formula as well while you are answering them all. The number of planks of dimensions it's given to you that can be stored in a pit which is 16 meter long. Okay, you can say that there are n such plank, and the volume of this is 4 into 50 into 20, and you can take it in meter by dividing by 100. This is the volume of one plank, and you can assume that there are such n such plank, and the volume is stored in a pit which is 16 meter long, 12 meter wide and 4 meter deep. This is a plank. Okay, finally you can cancel out these two zeros, and you got 5 2s are 10, one more zero got cancelled. N is coming out to be, this 4 got cancelled with this 4, N is coming out to be 12 6 is 72, 12 ones are 12 and 7 9, and one more zero will be here. 1920 will be the number of such plank. Yeah. Ninth question. Yeah, the length of the longest pole. Okay, whenever you want to find longest pole, you have to find body diagonal. I have already told you that, and I have told you the formula to find out body diagonal. Let's quickly go through that formula. It's here. The body diagonal for cube is root 3 times L, and for cuboid is root L square plus B square plus H square. If you go through this formula for cube and cuboid, you can try answering this question now. Question number 9. Yes, it is a cuboid. That's why you have to use the formula of cuboid, which is L square plus B square plus H square. Yes, 25. That is 100, 100, 200 and 25, 225. Do you know the square root of 225? You should remember the square of initial 30 numbers. I just want you to remember the square of initial 30 numbers. That will be very helpful in your calculation. Like square of 1 is 1, square of 2 is 4, square of 3 is 9, for 4 it is 16, 5. Okay, let's write down this quickly. Tell me quickly. Let's complete it, this table. 7 square is 49, and the 8 square is 64, 9 square is 81, and 10 square is 100. Then do you remember the square of 11? 11 square is 121, 12 square is 144, 13 square is 169, 14 square is 196, 15 square is 225, 16 square, yeah, this we were doing, okay. 16 square is 256, 17 square is 289, 18 square is 324, 19 square is 361, and 20 square is 400. And I will suggest you to remember up to 30 at least. 21 square is 441, 22 square is 484. Okay, now there is a pattern that you can observe. Initial 2 digit will be 4, then there will be 5 here, then there will be 5 here, then 25 square. Do you remember I have told you a trick to remember the square of number that end with 5? Any number that end with 5, if you want to find the square of such number, there is a trick I have told you earlier. Do you remember that trick, Kabir and you all? Yes, last two digit will be 25 and you will increase this 1 by 1 and you will multiply these two. You will increase this 2 by 1 and you will multiply this 2. You will increase this 3 by 1 and you will multiply these 2. You will increase this 4 by 1 and you will multiply these 2. 25 will be in all of them. 25 will be in all of them. 25 will be last two digit in all of them, and for initial 2 you will increase it by 1 and multiply then. You will increase this 6 by 1 then multiply then. For 75 square you will increase 7 by 1 and then multiply them. For 85 square you will increase 8 by 1 and then multiply them. And here you will increase 9 by 1 and then multiply them. Here you will increase 10 by 1 and then multiply them. This is a trick that you can find, you can use to find the square of all the numbers that end with 5. Similarly, for 26 square, there will be 6 and these two digits will be here. For 27 square, there will be